Okay, so hello everyone. This is the second technical walkthrough for the Shardeum boost, and this time we're discussing Shardeum Ancillaries boost, which is the second one currently live on the Immunefi webpage, and it's a fully Web 2 boost. This is actually, I don't think this ever happened on Immunefi. This is like first time ever, fully Web 2 boost. We're joined here today by Mehdi from Shardeum side, who will cover the code base and will provide some valuable insights. And from Immunefi side, it's, as always, me, team, and Alejandro from our technical side of things. That being said, Mehdi, Ale, please take it away.
Hey, I'm Alejandro. I'm a triager at the Immunefi team. Been with Immunefi for a little over 2 years now. And I'll be helping host this call, basically fielding questions from the chat for you, Mehdi. It'd be good to get an introduction from you.
Sure. My name is Mehdi Sabrawi. I'm the security team lead with Shardeum Foundation, and should be joining us here in a few minutes is Tim. He is a senior security engineer here with Shardeum. So this boost, as Timothy was saying, is completely Web 2. And the idea behind splitting up the Shardeum Foundation bug bounty into 2 boosts is because one, it's a large code base, and 2, there does seem to be like 2 separate components where there can be a range of expertise. And so it kind of made sense to split it up this way. This boost, it covers 7 repos, which is more than double the other boost. But these repos, in my opinion, this is my expectation, and feel free, white hats, to prove me completely wrong. I believe that this boost is probably going to be a little shallower and a little wider than the core boost. There's more components here, but these components, they're a little simpler. They mimic other networks a little better. So like one of the repos here is the Explorer repo, which is very similar to how the Explorer works in Ethereum. So if you're familiar with that, you'll probably have a lot of expertise to bring over into this boost. That doesn't mean it's less. The total payout is a little less, but there's more bugs to be found. There's probably a shotgun approach that you can take to find more bugs here and get more but smaller payments. And I personally do not think so, but there could be ways to steal money in this boost. I'm all ears for the white hat community to prove me wrong there. So let's get started a little bit by going over, let's see my notes here. So as usual, it's the same with the previous boost. I'm going to link this in the chat, the high-level architecture of the Shardeum ecosystem. And this is the same link from the previous boost. And this goes over a high level of how everything works, the place of every component in the architecture, in the system, and even a few, I think, let's see, a couple of these repos might not be covered in this high level because they're a little more internal, but we'll cover them here in this overview. So the first one I want to talk about is the validator GUI. Here's the repo for the validator GUI. There's probably not much in just like sharing the screen for this repo, but I can talk about it a little bit. So the Shardeum network is composed of a bunch of nodes. Ideally, each node has its own individual node operator. And the node operator, depending on the technical skill level, they might just be your average everyday computer user and not really a super user. So we provide a GUI for them to manage their node. And this GUI is just a point-and-click interface that allows them to, stake their node, add it to the network, some minor configuration things and whatnot. So this GUI is completely Web 2. But there is one important thing that I want to highlight about the GUI here. When we were internally creating this, when we were first creating this, we had assumed that the GUI would not be available on the wide open internet, that people would, just have their GUI available locally on their home server, or if they are running their node in the cloud, that they would have to log into the cloud provider and access the GUI that way. But we found through our test nets that our users like to have their GUI on the open internet. So it broadens, it increases the impact and importance of vulnerabilities in the GUI, because a lot of these GUIs are going to be available on the open internet. So if I'm thinking in my mind, okay, you could probably search and find all of these GUIs via Shodan, and also you'll probably be able to find the IP addresses. So if you find something in one GUI, you'll very likely be able to affect most or all of the nodes in the network. So the GUI is very important here. The next repo I want to talk about is the CLI. The CLI is how we internally manage the nodes. It allows a node to be managed via script, or just if you just prefer using a CLI compared to a point-and-click interface. This is what it's for. And the validator GUI internally creates commands on the CLI, and that's how the GUI manages the node. So the CLI we found is not usually available on the internet, on the open internet. Our assumption is that it will not be, and the user will have to do some special stuff in order to make it available on the open internet. So that's one assumption that's different from the GUI. However, everything the GUI can do, the CLI can do, and more. So and there's a connection between the GUI and the CLI. So there's room for bugs and vulnerabilities and payouts there. All right, the next thing is the archive server. I touched briefly on the archive server a little bit in the previous boost walkthrough. Let's see, where is it? And the role of the archive server here might be a little different than in other networks. So we see here we have our validator network. This is the Web3 part. All these validators, they're centralized, distributed, they're consenting on transactions. And once they consent on a transaction, they send that transaction to the archiver network, which is this level right here. This archiver network, our goal in the future is for it to be completely decentralized and distributed, similar to the validator network. However, our target at launch is to have it be centralized. It's not quite ready, and we have to budget developer time in order to hit our launch dates. We're going to centralize the archiver network and have it controlled by Shardeum Foundation initially, and then decentralize it after mainnet. So what that means is that archiver is Web 2, and it contains the whole history. Oh, hey, Chris. So Chris Friel's joined. He's a head of QA here at Shardeum Foundation. Anyway, so what this means is that the transaction history of the network is stored on the archivers, and the archiver will become the central point where external resources can go run diagnostic statistics on the network. You can look up transactions via the Explorer that uses information from the archivers. And you can see that here. So the archivers gather the info, and then from there it's spread to the Explorer. It's spread to wallets, distributed application UIs, exchanges, gateways, what have you. This is how the outside world gets information from the network, is through the archivers. And that's because only the most recent transactions are stored on the actual network itself. The history of the transactions are stored on the archivers. Let's see what's next. Looks like, so the relayer is next, and this is spread over two separate repos, the collector and the distributor. By the way, Chris, if I'm saying anything wrong, if you notice anything wrong, please feel free to join in. So the distributor and collector, these are not user-facing. These are internal services that allow the different components in the ecosystem to communicate with each other. So it allows the archiver, you see there's a distributor service on the archiver right here. Collector services on other components talk to the distributor, and that's how they exchange data. Let's see. The next is the JSON RPC server I'd like to talk about. So the RPC server is very similar to the role of the RPC server in other networks. So if you have experience in other networks, please use that experience here. It'll be very relevant. RPC server acts as an API for our network. So external apps, wallets, users, they can inject their transactions via the RPC server. They don't need to use the RPC server if they don't want to, but we make it available, and it's easy to use, readily available. And let's see, what else about the RPC server? Oh yeah, so there's a little bit of a complication with the RPC server that I want to highlight, and that is what we call local data. It's we've expanded the capabilities of the RPC server to run basically a dummy validator within it, and that allows the RPC server to locally kind of pre-run the transaction, get a good estimate for how much it'll cost in gas fees and other performance issue related concerns for the user, and give that estimation to the user. So the RPC server can get a little more complex. And while I don't see how vulnerabilities in this like dummy validator, we call it the service mode validator, could affect the overall network, once again, the white hats, please prove me wrong. We could absolutely be mistaken. There could be critical bugs in the RPC server up and down. I could also potentially see, since the RPC server kind of acts as the gateway in most external services will use our RPC servers, that if you could shut down all of the RPC servers or in some way modify transactions going through them, then there could be some critical vulnerabilities there to look for. Let's see. Finally, we have the Rust code in libnet. Let me see. Yeah, so we call it Shardisnet internally. We call it the Rust code. So this is the very bottom layer of the Shardeum, the Shardis stack. This is the networking code. It's all built in Rust. And I want to say, if there's any Rust nuts out there, Rust is not the primary expertise of our development team. So we are absolutely expecting any Rust nuts out there to dig through this code and find a bunch of inefficiencies, vulnerabilities. You have at it.
Mehdi, I connected as under my personal account, so I can add something about this.
Yeah, sure.
Yeah. So briefly, the Rust part is connected, splitted to obvious two things. Like it's a listener, like receiver part, and the sender part. And the main thing that we have two versions here with the for the protocol. It's a protocol with header and protocol without header. So where the vulnerabilities can be potentially is that some of the fields can be duplicated in a header and in the body of the message, and some of the handlers can use one of them, some of the handlers are using another of them. So you can kind of try to investigate inconsistency here and try to find some real kind of bugs, from my opinion. Yeah. And the second issue is I think the Rust code is doing some kind of maybe redundant buffer copies. So this can be also kind of source of some performance maybe issues, or even kind of denial of service kind of things. Yeah.
Yeah, I don't think any strictly performance related bugs are in scope for the bounty, but if you find something that is like an overwhelming performance penalty, feel free to submit it.
Yep.
And we'll discuss it internally as to whether or not it's in scope or a payout. It's one of those, Tim, if you could help, like the extenuating circumstances, primacy of impact. There could be high impact
Correct. Yeah.
on vulnerable things in the Rust code. So yeah. And so I believe that was pretty quick. That covers the repos that are covered under this boost. I want to. So here's an example of the Explorer GUI. This is a live one running right now, and it's very similar to the Ethereum Explorer and other explorers that you might have seen. In my opinion, there's nothing here that you'll be able to steal funds or affect transactions directly. But feel free to prove me wrong on that. And also, there could be areas and room for vulnerability finding here in how the Explorer connects and receives data from the archive servers. I believe that we're thinking about, from a user perspective, a transaction is not finalized until they can see it on the Explorer server. And that's just like a simplified way of looking at it. And internally, a transaction is finalized way before that, but for the average user, they probably will not think of it as finalized until they can see it on the Explorer server. So if you find ways to mess with that, that could mess with the end user experience and lead to some payouts. Probably not critical payouts, but some payouts nonetheless. The Explorer will be running some Explorers, and the bug bounty covers the ones that will be run by Shardeum Foundation, but there's no limit to who can run an Explorer. Similarly, I'd like to discuss briefly our plan for the archive server. So initially, when mainnet launches, they'll be centralized and run by the Shardeum Foundation. However, we hope to open that up so that third parties can run the archiver. And our initial plan at the moment is for those third parties to kind of make money with how they package and prepare that data for the external services. None of that is set in stone, but it's just giving you an idea as to how we plan to use the archiver servers and services in the future. So if you're able to disrupt those plans in any way, that would be open for a bounty collection. I think that's about it. This is a wide but shallow boost. There's plenty of code here that could be vulnerable. So if there's any question, that would be the time to ask for it. Not really a ton to go in on right now. Let me check the list of known vulnerabilities here to see if there's any insights. Okay, so these would probably be valuable to go into to understand the role of the archive server in our network a little better. So right now we're aware of a critical dependency on the archivers. It's the only full history of transactions on the network, and the archivers are centralized and currently not distributed or any sort of Web3 philosophy in their development. We hope to change that going into the future, but right now they're critical. So if you can take the archivers down, you could take the history of the network down. It wouldn't take the network down itself, but it would take the history down, which would lead to all kinds of secondary and tertiary problems in the community, in the broader community. Let's see, missing validation of active node list in network consensus process. Tim, are you familiar with this?
Missing validation unactive node list in network consensus, a function responsible for the face list of yeah, I think the solution was to use the robust query. So
this will be fixed.
Should be fixed by using robust query. Yeah, but there is no verification that the list of nodes is correct. Yeah.
Gotcha. Okay. So RPC server trust archiver a little too much. So this is one thing that we're aware of, in that because the archive server and network is a little too centralized right now, the trust is kind of screwed up. It could trust the validators a little too much. The RPC servers could trust the archivers a little too much. If you find trust issues with the archiver, please submit them. They might or might not be in scope. I understand that's frustrating for a white hat to hear. Is like, oh, you might spend a lot of time on this bounty and it might not be in scope. But if you have a good POC and a good explanation, we'll try to do the best that we can to get you paid, because those are still valuable insights. Let's see, exposure of debug endpoints in production mode due to lack of, that is in the RPC server. So there are debug modes in both the RPC server and the archive server. If you are able to access those debug modes while those components are in production mode, then that's worthy of a payout. Anything that requires the service to already be in debug mode is out of scope, but if it's in production mode and you can access these endpoints, then that's a payout. Let's see, lack of validation and received data from validators least substantial archiver compromise. Okay, so this is another trust issue with the archiver network. Yeah, the archiver, this is part of the reason why we put it in this boost instead of the Web3 boost, is that the archiver is very much Web2. There's a lot of trust in the archiver. We would like it to be trustless, but it is going to be launching mainnet with all of this trust. So if you can violate this trust in any way, that's probably going to be a payout. All right, I think that is all for me. Tim or Chris, if you have anything to add, please do. If not, that's fine. We can.
I just want to pay attention on validator GUI is that it's using the kind of not a good way to run validator CLI using kind of generated shell commands and running these shell commands.
Mhm.
Probably there can be some possible attack vectors there on a validator GUI. So pay attention on this repo.
Yeah, the connection between the GUI and the CLI. There could be vulnerabilities there. So I see the question from Test. Are these known issues, or they're usually not eligible for payout? So they are known issues, and the reason I bring them up is to highlight the role of the archiver and how we treat trust with the archiver. So these specific issues will not be paid out, but if you can find something along these lines, it would probably be paid out.
While we're waiting for some more questions in the chat, I did have a question actually related to the validator GUI. I know that you mentioned that people are starting to open them up to the internet. Is there some kind of authentication that a white hat would have to show that they can bypass before they can demonstrate an impact, or is that GUI kind of more open and available?
So that's good. Yeah, there is an authentication. So to demonstrate impact, we're assuming that the white hat does not have the password to log in, the username and the password to log in. So if they have the password, then there are bigger problems, and that's out of scope. But if you can do anything without having the password, that's a payout. That's a good question.
Okay.
Yeah,
awesome.
we were at least this was very early on in the process, like our first test net, where we realized that people were running GUIs on the open internet, and it was a shock. It was a part of my learning experience that there's a huge difference between like the Web3 white hats, the Web3 developers versus the Web3 users, which is the goal of what we're doing here. We're trying to make it very easy and accessible, and this is something that we had not thought of. This is a requirement for accessibility.
Awesome. Yeah, appreciate you answering that.
Mhm.
I have another question from here, which is, were there any challenges to your security assumptions or threat modeling that you were unexpected from audits that you received?
So the GUI was one of them. Beyond that, yeah. So as part of the reason why I harped on the role of the archiver a lot is not only the misunderstandings, but also our own misunderstanding of how trust worked practically with the archiver. Because our initial thinking was that, okay, the archiver network is going to be decentralized, it's going to be trustless. No archiver is going to trust any other archiver, no archiver is going to trust any node, or vice versa. But practicality and deadlines and whatnot kind of changed that assumption. So now there is trust in the archiver network. And that's a good question, because I do want to highlight that owning a malicious archiver and being able to compromise other archivers are in scope for this. So if you're able to break into, hold on, sorry, let me rethink that. If you're able to break into an archiver and affect other archivers, that is in scope. If you assume that you own an archiver, then that is less in scope and might be, the criticality might be lowered a little bit, but we'll still listen to those sorts of things, because it's our future plan to have that be a trustless environment.
So I can rephrase it like, if you don't have like a foothold to the archiver, but knows how to kind of escalate something on archiver when you get some initial thing, it also can be considered like by our team, like reviewed by our team.
Yeah, it's a mitigating circumstance if you're assuming that you already have a foothold, because that makes it a little more complicated. the way that we're launching. But yeah, we'll review it.
But archivers are very critical in our infrastructure because they holding the history of the blockchain. Yeah. I can even add more about that. Consider archiver databases like a distributed, especially transaction part, more as a distributed database, not as a blockchain in a general kind of classical understanding, right? More blockchain related stuff is our cycle chain, the chain which is related to the network structure. But transaction related stuff is more like a distributed database, decentralized, in our case centralized, but in the future decentralized distributed database. Yeah, archivers are very important. Critical.
I see here. Can we confirm there is no specific commits in scope, and if an issue is fixed during the boost and it is reported, say a white hat is working from an earlier commit, it would be out of scope. So the dev branch is in scope, and that's for all of the repos. The dev branch is for all of these repos, can be considered under development. If you submit your bug and your proof of concept before we have a fix in, then your report is valid. If you submit it after we have a fix in, then the report is invalid. So I mentioned this in the previous boost that before you submit your report, make sure you pull all the most recent changes on every dev branch that's involved with your POC and make sure your POC still works. If it still works, then submit your report. Anything else that might be?
Maybe it relates also to the question, the last question relates to if commit relates to some part of the system which is out of scope, it will be still out of scope, right? Let's say consensus mechanism, which is out of scope of the bug bounty, correct?
Can you rephrase that? I'm not understanding.
Let's say we have commits related to the consensus.
Mm-hmm.
Consensus is out of scope of the bug bounty, correct?
Of this bug bounty, it's in scope for the other boost.
Okay. So for the next boost, you mean?
We'll probably have to talk about this offline. But the consensus, everything in dev branch according to the dev branch configuration is in scope, and that includes a consensus.
Okay. Yeah. Never mind.
Yeah, sure. Also, I mentioned this in the previous talk that a lot of components in this boost interact with components in the other boost. If you're not sure which boost your vulnerability or your report applies to, just report it to either one. It doesn't matter. If we internally feel that it should be in the other boost, then the most we'll do is close your report and tell you to submit it to the other boost. So you don't have to worry about not getting paid for that sort of thing. Don't worry too much about which boost it applies to. We'll figure that out and make sure you get paid if it's a valid report. Chris Frails, an internal person, asking what branch of validator GUI is in scope. Dev branch of validator GUI is in scope. We had some internal discussions about this the past 24 hours, and we've settled on dev branch being in scope. The current plan is to launch mainnet with dev branch, or with the validator that's in dev branch, the GUI that's in dev branch. It's an active and changing code base. I understand that's frustrating for white hats, but you got to do what you got to do, and we appreciate your help. I guess because it's active and changing, that means that there's some immature code that's made it to dev branch that should be easy to find vulns in, so you'll get paid. Not your problem. It's our problem. Yeah.
Cool.
All right. I think
Any
we're
more questions? Yeah.
Yeah. I was just going to say, I think we're slowing down on questions here. So, yeah, last chance for questions. Tim, did you want to say anything here?
Oh, no, definitely not me. Come on. I know what you're talking about, but no questions from my side. Okay, guys. Yeah, I think we can wrap it up here. Half an hour technical walkthrough. We're pretty fast today, but I think, well, the sooner the better. Once again, we're having an open chat with Shardeum team members, including Mehdi and other team members in Discord. And we have 2 separate chats for 2 separate boosts, one for boosts, the Ancillaries boost, the other one for the code boost. So please go there in case you have any questions after maybe watching this in the recording, which will be live tomorrow. Yeah, tomorrow. That being said, thank you everyone who attended this live. Very pleased to see all the faces, well, at least your avatars here. Can Immunefi enable private threads? Do you have anything to hide, sir? Yes, sure, we can. In both boosts, I assume, right?
Yeah. So okay, a note on private threads is that we're generally pretty hesitant to answer questions in private threads.
Yeah, good point.
Yeah, because from our perspective, so the questions we've seen in private threads so far, like they would benefit the entire community. They haven't really been like, oh, I'm looking at this specific piece of code and there's a phone here. I don't want to, tip my hand to the other people in this competition. They've been more about like, well, how does this piece of code work? And that's beneficial for the entire community and the entire competition. And we want to spread awareness and understanding among everybody. So you might get some answers in a private thread, but do the best you can to ask in the open thread.
That's a very, very good piece of feedback. Thank you, Mehdi. I still activated them for both channels. I think they were activated for either of those. They're now activated for both. Please don't use them too much, because Mehdi will ignore you. He told you. That being said, guys, thank you everyone for attending this session. I think it was very, very, very good today. Once again, go to the Immunefi website, check out all the assets in scope, all the impacts in scope for Shardeum boosts, and grab those bounties, grab those bugs. Once again, thank you everyone, and see ya. Good luck.
Bye-bye.
Bye.